All right, welcome back, everyone. Can I treat it as a 2D array, but cannot treat it like a vector? Yeah. So if you have an int pointer is simply a memory address, nothing more, nothing less. Is it a 1D array? Is it a 2D array? Who knows? Who cares? It's up to you to figure that stuff out. So if it's a 2D array, that means it's going to be laid out in some format. You know, it's like you're going to have the first row first, followed by the second row, followed by the third. But it's kind of up to you, right? Like, especially when you're processing image data. Image data a lot of times can be held with a complete plane of red data, and then a complete plane of green, and then a complete plane of blue. Or you can do what's called interleaved or interlaced or something like that, where you do the red, the green, the blue for pixel at row 0, column 0, red, green, blue of row 0, column 1, red, green, blue of row 0, column 2. So the format, the layout of where the data is, when you have a pointer, like, it doesn't contain any of that information. It's just, where is the spot in memory? There's a spot in RAM right here, and that's where the image begins. You know nothing else beyond that. So if you want to pass in additional information, like how big is a row, how big is a column, then you pass those in as separate parameters. And that's why the code has a width and a height parameter. So it tells you how the thing is formatted. The rows tell you, you know, how long it goes until you get down to the next row, and or the columns rather tell you how far you go until you're down to the next row, and then the rows tell you how far it is till the end of the image, or the end of the elevation field. So I prefer using vector of vectors because it contains all that information. We may be getting matrices in C++ 23. Don't hold your breath. The standards moves not quickly, but there is currently some indication we might get matrices in 23. Coin toss whether or not that actually happens. But that'd be nice, because it's like these kinds of like things like come up, you know, like a 2D matrix. Wow, it's crazy. Somebody would want that in the standard. What kind of obscure use case do you have for a 2D matrix? Man. It'd also be cool if they added in support for numerical vectors, cross product, dot product, so that everybody and their mother doesn't have to write their own matrix library and their own vertex library, none of which are compatible with each other. That'd be kind of cool too, wouldn't it? I don't know. And then you could just multiply a vector and a matrix and a point and a... Yeah, okay. So our next topic is going to be Markov chains. Markov chain. So Markov chain is pretty cool stuff. Basically, you can imagine it's a graph. Okay. Stream? Oh, I'm not streaming? Okay. There. So, Markov chains are graphs, and the edges indicate the probability the transition from one graph to another. And so all of the outgoing probabilities must always add up to 1, right? Because 1 is 100%. So if we're on the E node right here, we roll a die, 10-sided die. If we get a 1, 2, or 3, we stay at E, we print E again. And if we get a 4 through 10, we print A instead, and then we're at A. And then we roll another 10-sided die. If we get, let's say, a 2, we transition back to E. And we roll a 2, we transition back to E. Roll a 5, transition to A. Roll a 5, we transition to A. And so this will randomly generate strings of just E's and A's. Not very useful. What is useful is when you take the English language and feed it into building a Markov chain graph. Okay? So for example, if you wanted to make a program that would generate random names for, let's say, a specific country, what you could do is grab census data for that country and grab just the first names, let's say, and feed them into this Markov chain generator. And what you basically do is you say, all right, for every letter you read, what is the probability that it moves to one of the other letters? And so there's 26 letters in the English language. So if I'm feeding in all the names of babies, you know, how often does the letter I follow the letter B? And you just count. You just count how many times each letter follows another letter. So you have a 26 by 26 matrix. And it's, you know, you just count. Every time a letter follows another letter, you count. And then you have two special letters. One is start of word, and one is end of word. And so you can count how often a certain letter starts a word. For example, U probably does not start a word in the English language very often. But like J would, even though J is not a very common letter in the English language overall. There's a lot of J names. So what you do then when you want to generate a random name is you start at it's a graph that you've essentially created. You normalize all those values down to, you know, 0 to 1. And you basically start at the start node, start graph, start vertex, and you roll a die. And then you see, okay, I rolled a J. Okay. Then you move to the J spot on the graph. And then J could be followed by O or U or I or A for James, you know, something like that. And then you roll a die, you're like, okay, you got an A. So you move to A. And then you see what letters follow A, you know, very often. You roll and you get a S, you know. And so you sit there and you move around. And the end word is one of the possible moves you can make. And eventually it'll move around and eventually it'll move on top of the end node and then you stop. And there's your random name. So Markov chains are great for learning patterns of data, and then you can randomly generate new names based on the patterns of the language or the country or the county or the city that you're trying to emulate. It's pretty cool stuff. Yeah. So I have a program on the server called MC Andre, because I think, yeah, Andre was his name. So I have a program on my server called MC Andre that takes in rap lyrics, and it randomly generates rap lyrics, and it has some additional constraints on it to make sure that the verses rhyme and things like that. Like it actually looks at the random data coming out and rejects those that don't sort of follow the, like if you're trying to go with a certain, you know, beat or number of syllables and rhyme pattern and things like that, then it will reject verses that don't follow that pattern. But the upshot is that it can randomly spit out, you know, okay, at least sounding rap lines. You should take note of this Markov chain concept. You should, because it's your next homework assignment. You're gonna have to do this. Okay, so more graph theory. Yay! Graph theory is fun. A lot of uses. Okay, so let's see if we can have a picture here. Yeah, like something like that. Okay. So let's say that you notice how the outgoing probabilities always add up to 1, right? So let's say you start at 1. And so you roll a 100-sided die. And you get a 72. Okay? So if you got a 1 to 23, you'd go to 2, but we didn't, so we're going to go to 4. So you output 1, you go to 4, you roll a die. And I got a 30. Okay, so then I move to 5. Then I roll another 30. Well, 100% of the time, I move to 6. So it's going to print out 1, 4, 5, 6. Do you see how this works? And it'll just keep moving around the system. At every point, you roll a die, and that randomly chooses which direction you're going to go in, right? So if it's raining today, there's a 60% chance it'll rain tomorrow. It's a 10% chance it'll be sunny, and a 30% chance it'll be cloudy. So if you want to generate fake weather forecasts for a video game, let's say, then you know, you're playing Harvest Moon or something, you probably want to start the game in sunny, because it's a little weird to start a game with it like thunderstorming, right? But it'll stay sunny probably for a while, and then, oh, it switches into cloudy, and then cloudy switches into rain, then it stays raining for a while, then it switches back into cloudy, then it switches back into raining, then it switches into sunny. And so you can use this to generate weather forecasts, you know, that, so rather than it going like sunny, rainy, it's kind of weird, you know, maybe not too weird for Fresno, given our weather the last couple of days. It was super windy yesterday, now it's just like dead, right? I was like all excited. I got my kites, you know, ready. And I was going to go to Woodward Park with my kites, and there was too much dust. There was so much dust flying up. I was like, all right, it's too windy for kite flying. I'll go tomorrow. Now it's completely dead. So, so does this make sense to you? And so you can use these things to generate, you know, fairly realistic looking and feeling. What is that? That's interesting. Yeah, that weather and words and things like that. So, weather felt like home yesterday. Now you're back in Fresno. Where is home, McCohen? West Coast Washington, yeah. Probably a little more dust storm than usual. Okay, so let's talk about Bridges Markov. So Bridges Markov. We're going to be doing, we're not going to be doing word generation. We're going to be doing sentence generation. So what we're going to do is we're going to feed in a corpus, a body of work. And what we're going to do is write down how often each word follows another word. Okay? So, for example, I put in 1,500 lines of Wu-Tang Clan lyrics. And then once you build it, it's basically just, you know, kind of a hash table. Right? You have a hash table where you hash based on the word. And then each word has a vector of possible words that it connects to and how often those words happen. And then once you build the graph, phase 1 is building the graph. Then phase 2 is generating new sentences. And you generate a new sentence by just picking a word, again, that connects to the start node. And then you roll a die. You're like, okay, well, this one's 75% chance. I rolled a 50. I'm going to go there. And you just sit there and you hop around on this graph until you get to the end node, and then you stop. So, for example, generating random, I fed 1,500 lines of Wu-Tang lyrics. My favorite Wu-Tang raps, not all of them, just my favorite ones. I put into this beast of a input, fed it into the Markov thing. It generated a graph, and then I had it just sit there spitting out Wu-Tang lyrics. And so I've got my Glock like Voltron, which I think is like pretty good, pretty line. I don't know. I'm stealing my Glock like Voltron. It's the name of your new rap band. That's a bar. My Glock like Voltron. Bring to mother, bring to mother. Bring it like it was kicking rhymes like you meth hidden caps on the jizza. Diluted, broken down, Yerua Smokey Bear when you don't need that Wu-Tang style. Like it's actually, like, not all of it's good. Like, some of it's just kind of like, you know, somebody's having a stroke. But, like, some of these are, like, actually, like, pretty good lines, you know? Chopping through your problems, the gods are hotter than heavy metal frame. Like, you know? And if you are a fan of the Wu-Tang Clan, you probably recognize the raps that some of these things come from, right? Stop quick, hold us, so grab your whole era. Like, I don't know what that means, but it's provocative. So, testing on the Declaration of Independence. I got this sentence. He has endeavored to the lives, our separation, and of English laws of our trade, with his assent to our Constitution, and hold them to dissolve the Supreme Judge of immediate and payment of consanguinity. We therefore, the most wholesome and magnanimity, the people in according element deriving their country to the conditions of the right. Yeah, the Declaration of Independence has some long-ass sentences in it. And so the odds of going to the end node aren't very high, and so you tend to get these very long run-on sentences, which actually do kind of represent the Declaration of Independence. To attend to the inhabitants of fatiguing them of an inwarrantable jurisdiction, foreign mercenaries to all experience hath shown that governments. Right, but I mean, this is a random generated thing, but it sounds like the DOI. You know what I mean? So, rap music's your favorite instrument. Load data from disk, 3 points. So this one is auto graded, I believe, and so when you run it, you can just print out your graph and quit. And so 3 of the test cases are based on that. So you load the corpus, you make a graph based on it, and then if the user hits 1, it just prints it, and then it quits. 3 points. Part 2, generate random sentences. You must use my random number generator. You cannot use your own because it's going to be auto-grading you based on the random rolls you get have to be the same random rolls I get. Okay. And then visualizing it on bridges is 3 points. Okay. So how do you load the data? Let's first of all take a look at this. M4. So this is Hamlet's the soliloquy from, was it Act 2 or Act 3? Soliloquy, yeah, Act 2. No, it's not that one. It's Act 3 then. Soliloquy, Act 3 soliloquy. Yeah, it's Act 3 soliloquy. Okay. So, to be or not to be, that is a question, whether 'tis nobler in the mind, to suffer the slings and the arrows of our age's fortune, or take arms against the sea of troubles by opposing in them, to die, to sleep, to dream, by sleep, to die, to sleep no more, and by sleep to say we end the heartache. Yeah. So, it's the whole thing. And so, we've got, you can feed this in, and then what you're going to do is every single word here, thousand, and life, and love, and after, all of these words are going to go into a hash table. And that hash table, because it's very easy to hash into it. It's very easy to find the record for after, let's say. So you go there, and it's going to have just basically a vector of all the other words that come after it, or a set of all the words that come after it. And every time a word comes after it, like death, you put death into the set. So you find after, you get it set, and you stuff death into it. And if it's already in there, you increase its count by 1. Okay. That's it. So what it looks like is this. So if we come up here, come into bridges, Markov.reference. So print graph. So here's the graph. Okay. So every word in the Hamlet soliloquy goes in here, and it's sorted by count. Okay, so 2 is the word that appears the most in the Act 3 soliloquy from Hamlet. Happens 15 times, and it starts a sentence 3 times, it ends a sentence 0 times, it has once a comma following it, and it has 15 words coming out of it. And it has 15 words coming out of it because there's no, it doesn't end a sentence ever. So every time the word to appears in the soliloquy, it has a word following it. What word's following it? Well, be follows it 3 times. Suffer, to suffer no more. By silence, in the heartache and the thousand natural shocks the flesh is heir to. 'Tis a consummation devoutly to be wished. To die, to sleep perchance to dream. Aye, there's the rub. To die, to sleep perchance to dream. So sleep would come up twice. You hear that? To die, to sleep perchance to dream. So sleep follows to twice in that little sentence that I said there. Load an Alex Jones rant. Oh, could you find one for me? I'll do it right now. Get like I need a lot of text, because Markov chains work best when you get I need a kilobyte of Alex Jones ranting, and I will put it in here, and I will make a brand new Alex Jones rant that nobody's ever seen before. Thank you. So you guys understand what's going on here? So this is all just using standard library stuff. Okay. Just gonna be loading from a file, one word at a time, Every time you load a word, you add it to the hash table, and every time a word follows a word, you add to the count. And so later on, when you do the random lyrics generation, then let's say we're on the edge, the graph vertex for 2, we roll a die. We roll a 15-sided die. If we get a 1, 2, or 3, we're going to output B. If we get a 4, we output suffer. If we get a 5, we output take. If we get a 6 or 7, die. 8, 9, or 10, sleep. Do you understand? And then we're now on sleep. Okay, so let's say we did sleep. Where are you? If you were asleep. Oh no, the happens. What is it sorted on? Oh, I guess it's just on the order that, yeah. I guess it's just the order they appear in the text. Okay. Question whether it's not really it's not sorted on counts, right? Where are you? Sleep. Sleep. There we go. Okay. To sleep. To dream. Perchance to dream, right? And so whenever you get to the sleep vertex, there are 3. So sometimes it ends a sentence. So twice when we got to sleep, it ends a sentence. And then 3 times it printed out a word instead. To sleep, to dream. To sleep, perchance to dream, sorry. Okay. And that sleep of death, what dreams may come when, yeah, so in that sleep of, yeah. Okay, so when we get to the sleep edge, we roll a 5-sided die. And if we get a 1 or 2, we end the sentence. If we get a 3, we print out 2. If we get a 4, we print out perchance. If we got a 5, we print out of. Okay. 'Tis a consummation devoutly to be wished, right? Consummation. And so what this is doing, it's learning the patterns of Shakespeare. Okay. So you're counting how many times words are appearing in a sentence. That's part of it. But what we're counting is how often a word follows another word. So if Hamlet says in his speech the word of, what word follows of? Okay? We're not just making a random count of like how common different words are, because then if you try generating sentences using that, you're just going to get nonsense. You're going to get like fortune, perchance, of, the. Outrageous, fortune of, the. Like you just get garbage. With a Markov chain, it's about what word follows what word with what proportionality. That makes sense? Wiki quote Alex Jones, all right. He's only 3 years older than me. That dude looks like he's, wow, okay. Dang. Like, I mean, let's be honest here. I've aged better than this guy. Like, can we agree on this? That guy, yeah. That's all. It's this. I don't like them to come on. Okay, that's pretty good. Okay, let's do this. Copy. Come into here and Vim Alex Jones there. Get rid of this kind of stuff. All the header and footer stuff we can get rid of. Quotes about Jones we don't need. These are all. You've chosen the path of pain. All right. Citations we don't need. The Alex Jones show. So I think we need to delete all of these lines. The Alex Jones show. Ashcraft, how would you do that? How would you delete all lines in Vim that have Alex Jones show on them? It's Ashcraft here. Oh, you cut out everything? Oh, okay. All right. Cool. That's even faster, I think. It's empty, dude. Cut out too much. When he said I cut out everything, you were definitely not lying. Okay. Your continuing donations help keep. No, get rid of that. All right. There's a war front. So you just need to get rid of all lines that begin with the Alex Jones show. So let's search for beginning with the. No, it's got indentation. Just search for the Alex Jones show. And we'll go DD and next a bunch of times. Record a macro, next, DD, stop recording the macro, replay the macro, and we'll just do this. Okay, fast enough. Okay, oh, it seems like it didn't get this one, the Alex Jones show. DD, next. Whoop. Over deleted. And then anything that has 2000 in it. DD and next. Oops. All right, good enough. All right.
Yeah, that was my bad with the empty file.
It was kind of funny though.
Got you a new one though.
Too slow. I already got it. Did you? Is it from the same source? Is it from a different source?
From the same.
Okay, let's take a look here. Alex. Okay, cool. Okay, so let's print the graph for Alex Jones. Let's generate some random Alex Jones. Generate random lyrics. How many sentences should we make? What do you guys think? How many Alex Jones rants should we make? George Soros or 7? Okay. There we go. Please enter the random seed 0. Okay. You don't think you're part of white men for you and a gimmick. You know, folks gotta love play a little bit wild today. Excuse me, I couldn't put on for no. And remember that as if they want to get back there. Nobody effing moment of cowardice is there, not even run your fault. You understand that gives me so sweet. Hitler, what I'm angry. Angry. But he was thinking, in fact, oh wow, delete this genius of Ireland. The most ancient Egyptian rituals. Some of liberty is what I'm not saying veterans are terrorists and rocks. They wreck and beat these insane people, and I want to have YouTube banning videos of that. This is the public had a bunch of white people just choking. You're not the Joe Rogan experience. Oh, my testosterone's going to lose. Most of the women across Europe. That is amazing. That is amazing. You're not the Joe Rogan experience up, but my testosterone's going to lose most of women across Europe. Didn't happen. Oh, my gosh. My gosh. Doing this, you're going to perception. Want to kill the same room with me. You know, your life and my spirit is cool. I can unlock a 55-year-old, ate a pile of myself. Two other people that wanted the gun stealing. Now there's real culprit suicide pills. Alec Baldwin thinks they're not being up and we're a GD to be proud of anti-human trash. The reason you sons of it and out from other do whatever you do. This isn't pure evil. You're so royal. We're such a devil. You know, we're all over you. Win, never. Never said that attitude when they have you. You're I want to lick the guns. How much didn't happen? Parasites will return. I gotta do a few more. I'm sorry. This is too amazing. Generate random lyrics. We'll do 7 more with a random seed of 1 this time. Okay. Is this the same one? No. Oh yeah. Okay. Alex. Oh, dang it. Infowars.com. Liberty is there, clearly used to your stinging guts. Well, I've talked to get free will and staring at her. Yeah, they're going to break your mommy and praising Satan. We're about family name. In fact, that you think I'd roll up killing me a mustache you were looking up against her. Well, I've told them I'm not their organs. We're going to act like they're like this country over us. Give up in this whole life. A 150-year-old swam 2 miles away and harvest their heads, disappear them. Take that, they're tough and effing pants at the troops. These people off it just can't find the stuff that's what to do, and you want to catch them. Calling Dana Loesch a car, a real culprit, suicide pills, mass murder, Africa invasion force. This because they want to have the smiling, leering devil, the ultimate buffoons, the good knock, then come from me. Damn. What do you guys think? Pretty accurate. I don't know. I gotta save this one. I'm gonna have to write this one down. Yeah, that's just too funny. Some of these are even, like. Can we have a copy of it? Of what? Of the... what do you want a copy of, Ashcraft? The paragraph? Oh, yeah.
Paradigm of absolute control. That's why we're centered on simple things, pointing out that we're meant to be in nature and be natural. And this is where we find the source that God made to transcend the New World Order. That's why they want to try to keep us out of it.
All right, there you go. So that's peak computer science for today, I think. Okay, so let's talk about how to do this, right? So if you look at name.cc, we're going to be using hash tables, which is an unordered map, right? And let's see. Do we have a hash table of hash tables? Is that how we do it? No. Just have a vertex of edge. Okay. So a vector of edges. So probably could be improved with a set. Okay. So basically every edge represents the word that you're connected to and the count of how often you go in that direction. So if you've got a bunch of words, and for the word Joe, if 99% of the time the word that follows it is Rogan, then Joe would be a vertex, all right? And it would hold the word Joe there. Count is how many times the word Joe appears in the entire corpus. And then it's going to have edges to all of the words that follow it. So, for example, there's Holloway Joe and there's Joe Rogan experience. So like maybe 99% of the time Alex Jones says Rogan following the word Joe, but maybe one time he says Hall after Joe. Then your vector of edges would have two elements in it. The first would be an edge holding Rogan with a weight of however many times the word Rogan followed Joe. And then you would have a second element in the vector holding the word Hall, for like Holloway Joe, the sea shanty, of course. And then that would have a weight of 1 because it appeared one time after Joe. You guys understand? So this is the data structure we're going to be using. So we're just going to have a hash table, right? That's cool. I've already got a double left arrow operator done for you, so you don't have to even format all that stuff. It just prints out all that stuff for you. That's cool. Functions to uppercase phi, functions to lowercase of phi, functions to capitalize just the first letter. So when you generate random sentences, the first letter in a sentence should be capitalized and the rest should be lowercase. But the graph itself will have everything in uppercase. I wrote a function to strip brackets because a lot of the Wu-Tang lyrics would say like bracket, method or whatever, ODB. And so this function here strips everything within square brackets. Also, I think for maybe Hamlet and stuff like that, it'll have like Hamlet in brackets. And so this just strips everything out in brackets in the input corpus. Okay. Yeah, so here we go. So here is the data structure. The data structure, and this is why I now require 41 to take this class, because this class is built on the success of 41. If you haven't taken 41 with me, then I can go over how these things work. But it's basically a hash table, if you know how a hash table works. The key that we're searching for is the word, like Joe. And then the hash table is just it hashes between Joe and the index of the graph. So the hash table just does a quick lookup in the graph so that we don't have to search through the whole graph every time. Instead, if Joe is in index 50 in the graph, we say, hey, where's Joe? Index 50, cool. And then we jump to index 50 in the graph here, and this hash table here just makes looking up entries in the graph easy. And it's a vector of vertices, and each vertex has a vector of edges coming out of it. And each edge holds a word, and if you want to find out where that edge leads to, that word Joe or whatever, you can hash that, and it's like, oh, well, that one's at this index here. Rogan, it's at that index there. And so you can quickly look up where these things are in the graph. Okay. So the code to print the graph is done. So for every vertex in the graph, it prints it. But you need to do the code to load it. So you have to load the file. So you're gonna read through this file that holds all of the, hello world. Okay. So it's gonna read 2 words, and your graph will have 2 nodes in it. One is hello, one is world. Hello is a start node, world is an ending node. In other words, the only transitions out of world are to ending. So you can use that to test your code. Toad's style is immensely strong and immune to nearly every weapon when properly used. It's almost invincible. That's from 5 Deadly Poisons, I think. Also quoted by Wu-Tang Clan. Okay. So there's a couple really short corpuses, and again, you should test your code. Right, like make a little thing, like A A B A C, or something like that, and then your Markov graph will say 100% of the time B will be followed by an A. Okay. For A's, 1, 2, 3, 4 times, A is followed by another A. One time A is followed by a B. One time A is followed by a C. A starts a sentence one time. C ends the sentence one time. And that's the graph. Okay? You guys will have 9 days to do this. It's a fun project. Because you can take anything you want. You can take the entire B movie if you want. And generate new sentences, brand new sentences never seen before by humans that are in the style of the B movie. Or you can take Alex Jones and generate brand new Alex Jones sentences, or Wu-Tang, lyrics and things like that. I'll be strictly using hack political pundits. Yeah, we need to get like one of those text-to-speech engines, and just I wonder if that exists. We're basically out of time for today, aren't we? I wonder if there's like a Alex Jones text-to-speech. Has somebody done that? There's gotta be. Vocal synthesis, okay.
What the fuck did you just fucking say about me, you little bitch? I'll have you know, I graduated to top of my class in the Navy SEALs, and I've been involved in numerous secret raids on Al-Qaeda, and I have over 300 confirmed kills.
That's not quite too accurate, but yeah, maybe I can get that sentence text to speech in his voice. That'd be pretty fun. Google Translate, then just have it read it. Okay. But it doesn't have an Alex Jones voice, Okay. Any questions about the homework? Any questions about the Dijkstra's assignment? I think what I showed you was pretty much most of the thing, and I did turn on recording, so you're free to dig into the YouTube recording of it and fix up your code. So I want to see everybody getting 20 out of 20 on this, okay? A lot of people didn't show up today probably because the assignment was tough or something. Okay. Alright, so that's it for today, guys. I'm going to sit here and enjoy my Alex Jones generator. Oh, here's the B movie. Kind of a B community. Back to change, have some lights on steroids. What were with a human race? Ken, she's human girlfriend. Tea time snack garnishments. Bees are cut flowers and be a fellow. That's Jones. Oh my gosh. If selling it starts with the Foreign War Powers Act. Black uniforms grabbing a jellyfish slacker who were building FEMA camps in history, and a swam to the other duo. Oh, what if he was called a lot of a loser? You filthy vampire, like 11 people all over again. Put a nast. How do you set up bridges on a local machine? You have to go to the bridges.uncc, or no, it's bridges.github.io. It's got a download there. bridgesuncc.github.io. Yeah, it's got the downloads on there. Okay. And then, yeah, that's it. So if that was fun for y'all today, it was fun for me. So max flow, we'll do another minimal spanning tree. We'll do max flow, and I'll test your knowledge on Markov on the quiz today. Okay. All right, see you guys on Thursday, and I hope you all get your bridges done by then. Peace out.